has studies been so far?
This is okay.
Oh, okay. I can see that you are always busy studying, even late.
You said
I can see that you're always busy studying, even late in the night.
yes.
That's good. That's good. Your kind of seriousness is worth emulating. All right. Good. So we promised the other day to start with binomial theorem today.
Yeah.
And I hope you are very, very ready for that.
Yes.
Great. So let's just go on straight to action. All right. So you already told me that you don't really have problem with binomial theorem as a topic. And your
Yes.
main concern is with how do you call it?
Approximations.
Approximations. All
Yes.
right. So, but as a teacher, since I was not the one who taught you the main topic, I will just take the next few minutes to brush through the whole concept, what it means, and then what we can do. All
Okay.
right, good. So we said that binomial expansion, or according to what we have all learned so far, is as a result of expanding binomials, which are expressions having two terms. A binomial is an expression having two terms. So it's a process or it's a method used to expand binomials that are having higher exponent or very smaller exponent. All right. So like we know the normal binomial expansion that is used to expand uh, bracket to the exponent 2 is quite easy, which is a squared. When a is applied, a plus b all squared means a squared plus 2ab then plus b squared, right? Which is a
Yes.
very common phenomenon. All right, but the binomial expansion comes very handy when we are we have very high exponents or very small exponent. When I say very small, I mean probably having uh, fractions as exponent or something. All right. So we first of all know about the Pascal's triangle, which gives us the coefficients of the
Coefficient.
various of the various terms we are talking about. Good. And then we can also talk about the combination method, which simply means when we are giving anything, we use the combination method to expand, right?
Yes.
Good. So we go to the expansion and use of, let me just write that as a subtopic, expansion. Good. So here we'll be giving, how do you go? We'll be giving a binomial expression to expand. After which they will give us another one with something missing, or they will give us a real value where we have to express it to look like the one we have expanded with x, so that we can fix in the values, the value or the values of x to find the actual value. Is that not what you are talking about?
Yes, sir.
Good. So let's take an example to see. But before the example, these are facts I would like you to know before we go to the example, so that it will help in our solution. Okay.
Okay.
So the first one, or just write this, to expand. Sorry, to expand an expression of the form a plus x
Okay.
or exponent n. First one, so there I'm going to list some points. So the first point one, first write the expression in the form 1 plus x exponent n. Have you done that?
Yes, sir.
Number two, when n is a positive integer, the expansion of this one, 1 plus x all exponent n, has finite number of terms. Has finite number of terms.
Okay. Please let me read that again.
Yeah.
When n is a positive integer, the expansion of 1 plus x exponent n has finite number of terms.
Yes. I.e.
Okay.
i.e. n plus 1 number of terms. Are you there?
Yes, sir.
The next point. If n is not a positive integer, if n is not a positive integer, do you have that?
Yes, sir.
If n is not a positive integer, then the expansion does not terminate, and so then the expansion does not terminate, and so then the expansion does not terminate, and so has an infinite number of terms.
Okay.
Are you there? Note, note, uh, 1 plus x all power n is the same as n plus, no, sorry, 1, 1 plus nx plus n into brackets n minus 1 all over 2 x squared plus,
Sir,
let me just take this one. Yes.
please, is 2 factorial.
Oh, okay. 2 factorial is the same as 2. But you are bringing
Oh,
2
yes,
factorial.
yes, yes,
Yeah, it's the
it's
same as
2.
2. That's why. Yeah, that's why I didn't. But you let me just bring it for the sake of the records.
Okay,
So n into bracket n minus 1, n minus 2, all over 3 factorial x cubed plus, and it continues. Okay, just to
okay.
remind, just as a quick reminder for ourselves, the way you quickly call my attention to the 2 factorial, it means that we are good to go. All right, good. Then we can just take some examples now.
Yes,
All right. So the very first example we have here is write down the first 4 terms of the binomial expansion.
okay.
1 minus, sorry, 1 minus x or exponent 6. Let me just finish my cleaning so I can write.
1 minus x exponent
All exponent 6.
6.
Yes, 1 minus
So,
x all exponent 6. In ascending, in ascending powers of x,
okay,
the whole of that is a. Then we go to b. Are you ready?
yes.
Then we go to b. Use the expansion in a to find correct to 2 decimal places. Correct to 2 decimal places. An approximate value for an approximate value for 0.996 or power 6. Right? Have you written all?
Yes.
Yeah, so from what you have told me so far, it means that under normal circumstance, you wouldn't have been able to solve this, right?
Yeah, I would have been able to solve for A, but not B.
Oh, okay. All right. So together we'll do the A, then we
Okay,
go ahead to fix the B into it,
okay,
right?
okay.
So that means by the formula we just wrote, sorry, 1 minus x all power 6 will be equal to 1 plus 6 negative x, right? Plus, maybe we just have to forget about the formula and go straight ahead, right? 6,
Yes,
6 times 5 all over 2 factorial negative x squared, right? It's up to the fourth term. So this is the third term.
yes,
So we go to plus 6, 5, 4 over 3 factorial, then negative x cubed, right? Okay,
yes.
so using your calculator, help me find this answer quickly. So this is going to give me 1
1
minus
minus 6x
6x
plus 15x squared
ten squared
minus 20x cubed
cubed.
plus then three dots.
Okay. Okay. Maybe the dot is not even needed because we are not
Okay,
continuing. We just
okay,
want the you get that. We just want it
okay.
out to the fourth term. So that is just okay for us to continue with our calculation. All right. So with this, now we are going to express. Okay, let me see. This is my board management. You are going to help me to write these figures again, okay? This last one.
Okay,
All right, so that I can clean the whole board and have enough space. So give it to me.
1 minus 6x,
Okay, let me. Oh, wait, let me write the
the main question.
main binomial.
1 minus x exponent 6,
That should be equal to one minus
1 minus 6x plus 15x squared minus 20x cubed.
good. So now we are going to express 0.0.996 exponent 6, right?
Yeah.
Convert to two decimal places. Right. So this one, our main aim here is to express this one to look like this without changing the value. Okay, that is our main aim. So how do we express this? The easiest way to express this is to subtract this from 1. Okay, when we subtract this from 1, the answer we will get will be the same as 1 minus that answer will give us this. So this minus 1, what will it give us? Check that for me quickly.
4 times 10 exponent minus 3.
No, sorry, without the exponent, just what is in the bracket. Because the exponents are the same. So we just want to have to make what's in the bracket the same, then it means that they will be equal.
So it is 0.004.
Right, so this is the same as 0.004. So if that is 0.004, then according to
Yes.
the explanation I gave you right now, it means that 0.996 will be the same as 1 minus 0.004 all power 6. Do you agree?
Please let me check.
Good.
Okay, so when I did it, I had 0.976 here.
No, because you
I
did
don't,
it exponent 6, right?
yes.
No, okay. So this is what we are trying to do. We are in mathematics, we do a lot of comparisons, okay? So we
Okay,
are saying that if what is here, let me use a red ink. We are saying that if what is here, okay,
okay,
is the same as what is here,
okay.
then this and this are already the same. So we just have to
Yes.
make this and this also be the same, then mean that the two of them will be equal. Because if
Okay.
what is in the bracket are the same, since they are carrying the same exponent, they
So
will give you
then,
the same final answer.
oh, okay, okay,
You
okay.
get me? Right.
Yes.
So what I just wanted you to do is that check whether we first of all want to know that this thing here is the same as what is here. Okay. So I just want you
Okay.
to do 1 minus 0.004 and see whether you get 0.996. If you get that, it means that we haven't changed anything in the bracket. So that's the first
Yes,
thing I
I
want
had
to
it.
do. It's the
Yes, I
same,
had
right?
it.
It's the same.
Yes, sir.
Great. So
Yes.
if it's the same, then now we are going to compare this bracket here. Let me use the red ink again. We are going to compare this bracket here. Let me circle it to this bracket here. to help us find
Okay.
the value of x.
Okay.
Okay, and then
Okay.
by comparing, we will see that the one here is the same as the one here.
Yes.
The negative here is the same as the negative here.
Yes.
Therefore, if we are saying that this one here is equal to this one here, the only way that can be possible is when x equal to 0.004. Do you agree?
Yes, sir.
So we will say that comparing 1 minus x all power 6 with, or even because we are just doing it to uh, because we are just doing it to the fourth exponent, we will just compare this one 2 to 4, because the question didn't ask us to expand the whole thing but just to the fourth term. Okay,
Okay.
or even better still, the final answers will be the same, but we will just do, because what is in the bracket are the same. It doesn't really matter if we do to the fourth or not. So let's just maintain the 6. This one will be equal to this. Comparing the two of them, x will be equal to 0.004. You agree, right?
Yes. Yes.
Good. So now the approximate value for this, question will be whenever we see x in the original expansion, we put
Yes.
0.004 there. Okay, are you okay?
Yes, sir.
So that is what we are going to do now. Meaning that therefore 0.996 exponent 6 will be equal to 1 minus 6 into bracket 0.00 plus 15 into bracket 0.004 squared minus 20 point, no, 20 into bracket 0.004 cube. So calculate that for us and let's see. Give me, for
I
the sake
had
of record,
0.97624.
wait, for the sake of record, give me the value for each of them so that we can do it systematically. Okay.
Okay,
So
so
this will give
1
us 1
minus
minus
0.024
plus
plus then 2.4 times 10 exponent minus 4
2.4.
times 10 exponent minus 4.
So that is in a standard form. Can you change that for me?
Yes.
That is 0.00024, right?
Yes.
Then
Then minus
let
1.2.
me ask you, is that for what is in the bracket or with the 15?
It is for 15 times
Okay, everything,
0.00.
everything.
Yes.
Right. So what about this one?
1.28 times 10 exponent minus 6.
Minus 6. So that will be 5 zeros before the 2 what? 1 point what? 28.
28.
So that will be 5 zeros before the 128. I hope you know how to do that.
Yes.
So now add all of them for me and let's see what we have.
Yes. When I added all, I had 0.97624.
0.976
4.
24. Is that what your calculator gave you? Because all I advise you that always we should write the final answer before we approximate to whatever the answer is to.
Yeah, the calculator gave me 0.97624,128.
624,128.
128.
Okay. So now our final answer now asks us to approximate this to two decimal places. So this becomes
Yes,
what? 0.
0.98.
That is our final answer to two. Sorry, to two decimal places. Has it gone well?
Yes.
So if it has gone well, then let's give another try. Let's try another one.
Okay.
Can I clean the board?
Yes.
So let's take this one. Write down the binomial expansion of 1 plus x power 4. Oh, sorry, all of them power 4. That is A. Then we take the B. Use the result in A. Use the result in A to evaluate 5 over 4 power 4. Correct to three decimal places.
2.
To three decimal places. Correct to three decimal places.
Okay.
So with this, you can observe and tell me whether we should solve it together or you give it a try first.
Yeah, please let's solve this together.
Okay. All right. So we take the A by expanding this, which by the binomial expansion is going to give us 1 plus 4x, right? Plus
Yes.
4, 3, all over 2 factorial x squared. They said we should, we should expand all, right? Yes.
Yes.
This one we should expand all.
He didn't give any
Yes,
stated.
yes. So that means we are expanding everything. So that is going to give us plus,
So it's not stated, which means you are supposed to expand all.
yes, yes,
Okay.
yes. So this will give us 4 times 3 times 2 all over 3 factorial x cubed. Then plus 4 times 3 times 2 times 1 all over 4 factorial. And this is x power 4. Alright. So when we solve, this is going to give us 1 plus 4x plus, I think 6x squared, right? 6x cubed
Yes, plus 4x cubed
4x cubed. Good. Then this one, the
plus
factorial
x
will
to
go
the
away with
4th.
this. So this will be plus x to the power 4. Yes. So this is our final expansion. Then when we expand this, we are going to express this one in a way that it will look like this. So the
Okay.
first thing we need to do is to change it from the common fraction to decimal fraction, meaning that 5
Okay.
over 4 x power 4 will give us what? What do you have? Don't add the exponent here. Just do the power 4. You see, because again, this exponent here is the same as this exponent here. So if we
Yes.
are able to express what is in the bracket to look like what is in the bracket here, we have succeeded in making them equal. So that is what we are going to do. So quickly check that for me.
5 over 4 is 1.25.
Okay, so 1.25. Then we do exponent 4. Can you express this to look like this for me? To be like 1 plus something for me? Can you uh,
Please, I had
expand it?
when I changed this, I had 1 minus
Oh,
0.25.
okay, okay. Sorry. Okay, the first question we solved involved a minus. That is how we
Yes.
did a minus. But this one involved a plus. So 1 plus what can give you 1.025, 1.25. It's obviously 1 plus
Okay.
0.25. Check that and let's see. So this is the same as 1
You
plus
said what?
0.25. I'm writing it. Check it and see. Check 1 plus 0.25 and see whether you get 1.25.
Yes, you get 1.25.
Exactly. So it's good you said that. So the first one we did was subtraction. That is why we subtracted. We need to have it 1 minus something to give us 0.996. Okay, that's how we
Okay.
did the subtraction, because when we do 1 minus 996, 1 minus 0.996, whatever result we get will be the same as 1 minus that result. Oh, whatever
Yes.
result we get, 1 minus that will give us the 0.996. You understand? But here
Yes.
we are not doing subtraction. So we just need to, if I can say anything, I would say we just need to subtract 1 from this. Whatever answer we get, it means that 1 plus that
1 plus that.
will give us what
Yes.
is here. Are you okay?
Okay. Yes.
Exactly. So now that we have done this, we have our 1 here. When we compare, okay, so let me write that. Comparing 1 plus x power 4 with 1 plus 0 power 4. We will say that x equals 0.25, because when we compare the two of them, 1 is here, 1 is here,
Yes.
x is here, x is here, exponent 4 is here, exponent 4 is here. So if they are equal indeed, unless s is equal to 0.25, are you okay?
Yes, sir.
Good. So by getting that, about 80% or 90% of our question is already solved.
Yes.
So we are just going to fix that into this one. Sorry, now that we know the value of x, we're just going to fix this into our x. So that means that therefore 5 over 4 all power 4 is equal to 1 plus 4 into bracket 0.25 plus 6 into bracket 0.25 all squared plus 4 into bracket 0.25 all cubed plus 0.25 power 4. Give me the breakdown one by one.
Okay, so 1 plus
Just a minute. 1 plus.
1
Okay.
plus 0.375
4
plus 0.0625
plus 0.0625
plus 0.00
Write that one under.
390625.
Just a minute. 0. Just a second. 00. I had 39. 0.0039.
390625.
390625.
Yes.
Okay. All right. So now let's add all and see.
Sir, please, I had 2.4414.
Equals 2.441. All right. And our final answer is to how many decimal places? 3. So that means we are ending. This is the first second. We are ending our answer here.
Yes.
Right. Okay. So that gives us 2.441. This is 2. 3. Ventilation for it. Or is the ventilation already good?
Yes, it's good.
Right. Then probably okay. Anyway, but there's no problem now, right?
Yes.
Good. 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 You can still see from the board, right?
Yes.
Great. So let's take example in another form. An example that will
Okay.
stretch our understanding a little more than
Okay.
this looks more or less like normal. So let's take another example that will stretch our understanding a little more. All right. You ready, right?
Yes.
So let's take this. A. Expand 2x plus 1 all power 4 in descending powers of x. In descending powers of x. Then B. Using the expansion in A, evaluate 1.05 all exponent 4. Correct to 4 significant figures. Correct to 4 significant figures.
Okay.
All right. Would you like to give this one a try or we should do it together? Because this looks different. If you want to
Yes,
try,
please, I'll
fine.
try it.
Good. Good. Now let me give you some time to try.
Sir, please, I'm done.
All right. So what do you have?
Sir, please, I had 1.468.
1.468.
Yes.
Hmm. What did your expansion give you?
The expansion gave me 1 plus 8x plus 24x squared plus
1 plus
64.
8x plus 24x squared
Yes.
plus 64.
X cubed.
Hmm.
Then plus 16x exponent 4.
Oh, how did you do the expansion?
Okay, so see, the question gave us 2x plus 1 exponent 4.
Which,
And we need to write
which,
it in the form.
which is a little different from what we knew or we have done so far, right?
Yes.
You agree with
So
that?
please, you said
You agree with that, right?
yes.
Okay, so what did you do from there?
So what I did was you need to see the first term is 2x, and so you need to write the whole term, the binomial term in the form 1 plus x exponent n.
You were able to do that.
Yes.
Okay, what did you get from there?
What I did was that I factored 1 out. I factored 1 to the fourth out.
How do you
So
factor one? Okay, when you factor one out, what did you get?
when I factored 1 out, I had 1 plus 2x. Then I raised both 1 and the binomial 1 plus 2x to the fourth power.
1 plus 2x.
Yes.
Nana, are you sure this is your factorization? You did it well. But how do you even factor one out? Because anytime you factor one out, you have the same thing in the bracket, though, Nana. What do you think? Because factoring the thing out means that you want to achieve a goal. Anyway. So you let's go through. I think you have the idea. You have the idea, but the way you went about it is what caused the problem. So I'm going to try to use two methods to solve this, okay? One of them is the one of
Then
I can hear you.
I think I made mistake in the factoring. It's supposed to be 2 exponent 4 multiplying half plus x
Exactly.
exponent 4 round.
Exactly. That's what it's supposed to be. So that affected your answer.
Yeah, so my first answer is wrong.
Sure, sure. So should I allow you to do it again now that you got the factorization right? Or
Yes.
okay. So let me give you some more time
Okay.
to do that. Went ahead to expand.
Yeah, so coming back to the question again, I did my factorization and I had this one, what you had.
Mm-hmm. But this is what you should have by the way you wrote the question. Am I lying?
Yes.
This is what you should have by the way you wrote the question.
Yes.
All right. So you had this, right?
Yes.
So I want us to expand this to see whether we are going to get what you have.
Okay.
Uh-huh. So using the binomial expansion, I think this is 16, right? All right. So this is 16. Then we have 1 half x power 4 plus 4, 1 half x power 3 x. Then over 2 factorial, right? No, this is
No,
not
no, no.
over. This is not over factorial.
Yes.
So plus 4, 3, 1 over 2 squared x squared 2 factorial. Then plus 4, 3, 2, 1 half. Then x cube, right?
Cube.
All
Yes.
over 3 factorial. Then plus 4, 3, 2, 1 half exponent 0 is just 1. So then x power 4 over 4 factorial, right?
Yes.
So this is going to give us 16 bracket open. This is
1 over
1
16.
over 16 plus 1 over 8 times this. So it will be 1 over 2, right?
Yes.
1 over 2x, then plus. This one will cancel the 2 here. We have 6 times this. So 3.
So 3
No,
over 2.
I'm coming. So this is 6. This will be 4. I'm coming. Now 6. This cancel here 2, right? I'm coming. This cancel here we have
Yes.
2 times 3 is 6. 6 divided by 4 is 3 over 2. You agree? Because this is 1 over
Yes.
4, not 1 over 2.
Yes. So it's
So 3 over 2
3
x
over
squared.
2.
Yeah. Then plus this one cancel this. Then this one, so we
Yes.
get 2x cubed, right?
Yes.
2x
Then
cubed, right?
plus x to the fourth.
Then plus x to
Yes.
the power 4. Okay. Then now we use this to
Yes. This is
open.
what I had.
Yeah. So this is what you have. All right. Then from here, did you open the bracket first, or
Yes.
you went ahead
I
to?
multiplied. I multiplied everything here by 16.
Okay. So if you open the bracket first, then it means you are going to have 1
Yes.
plus 8x
Yes.
plus 24
24
x
x squared
squared plus
plus 32
32
x cubed
x cubed
plus
plus
16 x to the
16
fourth.
x to the power 4. That is what you have, eh?
Yes.
Yes. So if this is what you have, then it's correct.
Oh, okay. Because instead of me writing it as 2x plus
Yeah.
1, I wrote mine
That is what I
1.
said, that because addition is commutative.
Okay.
Because addition
Okay.
is commutative. You
So
change
it
it. I
means
don't
I'm
know why
right.
you, yes, I don't know why you change it, but because addition is okay, you said you it's a mistake you made.
Yes.
Yes, but
It wasn't
fortunately
my
for you,
intention to write it as 1 plus 2x.
good. But fortunately for you, addition is commutative. So
Okay.
it didn't really affect your final answer. All right. But then after your expansion, after you fix in the values, you said you got 4 point something,
No, 1.464.
1.464.
Yes. Or you see, with this, please, 1.05 exponent for I wrote it as in a form um
I'm listening.
okay, right, like that.
Okay, so you said in the form. I didn't hear the form in which you wrote it.
uh, okay, so the mistake is from where I started inserting the values for
But what did you get for
the
x?
x.
Mm-hmm.
With x I had 0.05. When I
0.05.
expanded,
I think there's a
yes,
problem with
one,
that answer.
yes,
So not the
because
fixing. The 0.05, there's a problem with it.
so if anything, I'm supposed to write 1.05 exponent 4 in the form 2 exponent 4 half plus x exponent 4.
Exactly. Either of them. It can be this way, it can be this way, or it can be this way. Are you okay? Or not so
Yes.
clear? It can be this way,
Right.
it can be this way. So maybe I have to elaborate a little more on that. Okay? Or do you want to give it a try?
Okay, let me try it.
Okay, then quickly.
I'll try it.
All right. Say that again.
Please, is the answer 2.320?
No, please.
Sorry, 2.321.
2.321. No, please.
Yes.
It's not.
Hmm.
It's, are you, are all your options exhausted?
You said
Are all your options exhausted?
No, no, no. I'm still trying.
Okay. Sorry, I missed everything. Come again.
1.216.
Good. I think you got it now. I think you got it now. No, no, I think you got it now. Good. Good, good,
Yeah.
good, good. So do you have any question?
No, I think eh,
The thing requires a
so
lot of
X is
attention,
supposed,
right?
yes.
It
So
requires a
X is
lot of
supposed,
attention to details. Is that supposed to be what? I want to hear that.
so X is 0.025 instead of 0.05.
Yes,
I
yes.
divided 0.05 by 2.
Great, great. That is it. That is it. The thing requires a lot of work.
Yes.
Yeah, so let me make, first of all, do you have a question before I make my general comments?
Oh no, I don't have any question.
Good, good, good. So the very first thing is you can see some asterisks here. When you were working, I made an asterisk here. So first of all, the question said you should, these are when you told me about you exchanging a position. I told you it doesn't matter because addition is commutative. But
Yes.
then I went back to the question. The question said you should work it in descending powers of x. I hope you understand that.
Yes.
So it means that this term, look on the board, it means that this becomes the first term, followed by this, followed by this, followed by this, and then this is the last term.
Okay. So after working it this way, you need to exchange it.
I'm coming there. So right
Okay.
now, if you ask me that question straightforward, I will say yes. You need to exchange because that is what gives you the answer they are looking for. But
Okay.
then my comment I wanted to make before you came in was that because of that, I don't know whether as the way you did it, the examiner is going to consider you or is going to mark you wrong.
Okay.
Because the question asks you to write it in descending powers, but now you have it in ascending powers. You get me? I don't
Yes.
know what that means for your answer and your method. Honestly, I don't know what that means for your answer. But I think because it doesn't follow the instruction, it will be too risky for you to do that. Since they are not marking only the answer, you get
Okay.
me? The final answer you can rearrange, but since they are not marking only the answer, I don't know what that means for you. So next time I will say that instead of me, how will I say, me just insisting that since you made a mistake, but this is commutative, so you work it that way. I would advise that you follow the instruction in the question.
Okay.
You get me? That is the first uh, comment. The second comment is that you see that I think you have to try like 3 times before getting it right.
Yes.
Yes, that only reveals that as we are working, we need to pay a little more attention to details.
Okay.
You cannot be too careful when you are working mathematics that involves a lot of steps. You cannot be too careful because
Okay.
immediately you miss out one thing, it is going to affect your final answer. So these are the two main comments I want to make before we move on. And then when you started, I was telling you that this one, there are two ways we can solve it. So one of them is what you have done now. And I think that is what I gave you at the beginning of this lesson. I gave you a note at the beginning that if it expressed in some way, you have to make sure you come and express it in another way. This one looks more or less like that. Okay. And then
Okay.
another thing I wanted to comment on is uh, I just remember that after stating those points for you, I didn't really take time to explain each of them. And I even forgot to ask you whether you understand each of those points I gave at the beginning. Okay?
Okay.
So let me ask that question first. Do you have any problem with any all the points I gave you from the beginning when you are working? Do you have problem understanding any of them?
So, please, the second point.
The second point.
When n is a positive integer, the expansion of 1 plus x exponent n has finished number of terms. That is n plus 1 number of terms.
Good. It's very nice we are on an example like this before you ask that question. So from that point, this is our end, right?
Yes.
Good. If this is our end, then n plus 1 means that the number of terms you have should be five terms. Do you get that?
Yes.
That is what that point is. So let's count. 1, 2, 3, 4, 5. You see?
Okay.
So that is what that means. So it means that if it is a positive number, integer, you know what an integer, a positive whole number, just as it is now.
Yes.
Then after expanding, your number of terms should be one more than. That is, if you are expanding all. We answered some questions earlier. We didn't ask it to expand all.
Yes.
But then if you are expanding all, then it will require that you get one more term than the exponent. That is what that point means. Are you okay?
Okay.
Any other? I didn't hear that. There was a breakage in the internet.
The place is okay. That's all.
Okay, that's all. Maybe I'll just quickly give you one question, one last question to solve. Let me give you another one which looks a little more like what we just did for me to be sure that we understand. Expand. Expand 1 plus 2x all power 7 in ascending powers of x up to the 10 in x cubed. Up to the 10 in x cubed.
In ascending powers of x.
Up to the 10 in x cubed.
So please, I didn't hear that part.
Up to the 10.
Up to the 10th.
Yes, in x cubed. Up to the 10 in x cubed. Are you there?
Okay.
Then B. Use the expansion in I above. Use the expansion in I above to evaluate 2.03 exponent 7.
Okay.
Correct to 2 decimal places. Correct to 2 decimal places. You try your hands on it, right?
Yes.
All right. So try your hands and let's end it. Okay. You are done, eh?
Yes, sir.
All right. So what do you have?
68.73.
68.73.
Yes.
Okay, share your answer, share your solution with me.
Okay. So this is the expansion 1.27 exponent 7. And we are asked to evaluate the value for 2.03 times 10 exponent 7. So first of all, you would expand 1 plus 2x exponent 7. And the question said we should expand to the third term. And so when we are expanding, we will end at the third term. And for my expansion, I have 1 plus 14x
When you're
plus,
expanding, you end where?
you end on the third term, which is x cubed.
Are you sure? That will be the fourth term, actually.
Okay. So I'm
Because
supposed to end at,
the first term will not carry x.
yes.
Are you with me?
So I'm supposed to end on 84x squared.
Exactly. No, not 84. You are supposed to end on 280 s cubed. Because you have to end on the s cubed term.
Yeah, that's what I did.
Yeah, but that is not the third term. That is the fourth term. Count your terms and see. Here I have the first term to be 1, second term to be 1 over to be 14x, third term to be 84x squared, and then fourth term 280 s cubed.
Yes.
You get me?
Yes.
So I just want to correct the terms, the number of terms I mentioned. Though it's s cubed, but because the first term has no x term. You get me?
Yes.
The s cubed term becomes the fourth term.
Yes.
Are you okay with that?
Yes.
So go ahead.
So when I expanded, I had 1 plus 14x plus 84x squared plus 280x cubed.
Okay.
So I changed 2.03 into the form 1 plus 2x. And I had 1 plus 1.03 exponent 7. But in the expansion,
Wait.
in the binomial,
The value for x has a problem. Can you figure it out?
yes, sir, please, you said.
You said you got your x to be
Point,
what?
no, I'm not done. When I
No, but
change,
you see, I'm coming. Because the value of x is what you have to fix in to get the right answer. If the value of x is wrong, we cannot continue with it.
okay, so my x is 0.515.
Your x alone?
Yes.
No, please.
No, initially my x was 1.03, but in the binomial expansion, we have the second term to be 2x. So comparing that with 1 plus 1.03, 2x is equal to 1.03. And so you divide both sides by 2 to get the value of x.
You get
which
2x
is
equal to 1.03. That is what
Yes.
I'm not getting. I don't know how you got the 1.03.
So you see 2.03, when you add 1 plus 1.03, you are going to get 2.03. As you taught me initially, that
Okay.
like
Yeah, so you have okay, I'm coming. So this is what you are saying. You had 1 plus 1.03, eh?
yes, exponent
Okay,
7.
okay, okay. Exponent 7.
Yes, then comparing the first binomial term with this one, 2x is equal to 1.03.
And our x
So
equals
we
what?
divide both sides by 2. And x is 0.515.
Okay. Then when you fix in, you got what?
Yes, so when I fit, I had 68.734345. And to 2 decimal places, it is 68.73.
68.73.
Yes.
Okay. So really, this is what I was expecting you to do, okay? Because the final answer is not really, it's not what is here. So let's go through and see. So this is what I was expecting you to get. That you have a, so like you rightly said, this is 2 plus 0 0.03, right? Is that also
Yes.
2.0, 2 plus 0.03 exponent 7? That is what you did, right?
Okay.
Is that what you did? Nana, can you hear me?
Yes, sir.
Is that what you did?
No.
Ah, what did you just tell me right now that you did?
I did 1 plus
Okay,
1.0.
okay, okay, okay. Sorry. You did 1 plus 1.03.
Yes.
Okay, 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 okay. I think I get you now. Okay, but this is what I'm expecting you to do. Okay, so that you have, when we finish, we'll try with what you did. But the fact that what you did gave you a different answer is making me suspect that there is a problem with the, the solution. So this is what I'm expecting you to do. With what we did earlier, from here we can factor 2 out, can't we? We can, right?
Yes.
So you get 2 exponent 7 out here. Then we get 1 plus. This one divided by 2, what will it give us?
0.015.
0.015 exponent 7. Okay? Then when
Okay.
we expand further, 2 exponent 7 is going to give us what? 128.
128.
All right. Then that is going to give us this. Okay, you let's come back to this. All right. So when we compare this, the inside one with this, it means that our 2x, our 2x will be equal to 0.015. Right. And our x becomes what?
0.0075.
0.0075. All right. So now we are going to fix this into your original distance, which is 1. We are going to fix that into 1 plus 14x plus 84 x squared plus 280 x cubed, right?
Yes, sir.
Good. So that means that with this 1 plus 0.0015 for 7, we go to 1 plus 14 0.0015. My connection went off.
Sir, please, I'm supposed to use 0.0075.
Yeah, 0.00. Thank you for that. 0.0075. Because that is our x. 2,775 squared, then plus 280 into bracket 0.0075. Okay, right. So by the normal multiplication, I think this one will give you 1 plus 0.105. Confirm each of them for me. Plus 0.047 25 plus 0.000 118. Confirm each of them for me whether they are right.
Yes. 1.109843.
1.109843.
Yes.
1.109843, right? But that is just the
Yes.
answer for this. You get me? But we are looking for the answer for this. Are you okay?
Okay.
So 2 exponent 7 times 1 plus 0.015 exponent 7 will give us 128 times our answer. And what did that give us?
142.00510
142.05.
or 0599. 0599.
And is that to what? 3
Decimal places.
to 2 decimal places rather. To 2. To 2 decimal places. So that will give us 142.06. You get me?
Yes, sir.
So, but I don't know why you got what you got. So let's try. So this is what I'm expecting you to do. Yeah, there was a problem with your network, so it went off. Or your laptop
Yes.
went off again.
Yes, it's the laptop.
The laptop.
Yes.
Okay. So this is what is expected of you. But then with what you did, I don't know why you didn't get the same answer. Okay. I feel like
Okay.
we should go through it to see. Or what do you
You
think?
said, please, you said,
With what you did, I don't know why you didn't get the same answer. So I feel like we
oh,
should go through it to see whether
okay.
there was
Okay.
a problem somewhere.
Okay.
You get me? So
Okay.
let's go through and see. Let's go through what you did and see what you will get at the end of the day. Okay, so instead of this, you have this. Let me see. You had this 1 plus 1.03, right?
Yes.
Okay, plus 7. Good. So by comparing the two of them, we said therefore 2x is supposed to be 1.03, right? Is that what you had?
Yeah. 1.03. Yes.
Okay, so we are
Divided
going
by 2.
through one by one. If we get
Yes.
something that we didn't get, then you tell me. So if that is x
Okay.
will be equal to what? 1.03 divided by 2.
0.51.
0.51,
0.515.
just 51, 515. This is what you got. 0.
0.515.
Okay, okay, okay. So now you want to fix this one into the expansion, which is 1 plus 14x plus 84x squared, right? Plus
Yes.
280x cubed. Okay, so let's work it again and see. 2.03 plus 7 is going to be 1 plus 14 times 0.515 plus 84, sorry,
Plus
plus
280.
280, yes, 280 divided by 5 cube. Do that and let's see. I'll be glad if we can get the multiplications one by one. So this is 1 plus
Yes. 7.21.
7.21. Give me at
Plus
least
20.
4 decimal places. Okay. For any of them, give me at least 4 decimal places. But let's
Okay.
go. Let's go. Plus
Plus 22.2789.
plus
38.24.
mm-hmm.
5445.
So this is what you got.
Yes.
After all these exponent and things.
Yes.
Okay, so add them and let's see.
Yeah, please. I had 68.74335.
Which is not equal to our answer, right?
Yes.
Okay, so this is the conclusion we'll reach. And so maybe we do further studies to be sure why that problem. The conclusion we
Okay.
reach now is that anytime you are working it, you have to make sure this one is 0 point something.
Okay.
You get that?
Okay.
I have not yet seen that for a fact in any book yet. But I think it will be safe to have that conclusion for now.
Okay.
until we are sure of otherwise. Okay.
Okay.
So myself, I'll do some work around that and see whether I can come up with something better to explain it to you all.